can't be there with all of you in Iceland, and I have to miss out on all the presentations in such an incredible setting. Thanks to Katie and Joe for representing our team. I'm going to briefly introduce the course. Out of Practice is an elective seminar for graduate students, primarily from our MArch program. The course adapts methods from evidence-based entrepreneurship, which is abbreviated EBE, to help students learn ways to leverage their design expertise beyond traditional architectural practice. Evidence-based entrepreneurship, also known as the lean startup methodology, is a systematic approach to business development that emphasizes learning at the early stages before substantial investment is made. Popularized by Eric Ries, this methodology has gained a following among tech industry executives, startup founders, and aspiring entrepreneurs as a way of confirming a good fit between product and market. Similar to its application in the private sector, the NSF's I-Core program trains academic researchers in this approach to learn early on in their research development what problems their innovation might solve. A central principle of this approach is for the entrepreneur or the academic to get out of the building, or stop focusing on the product or the innovation in a vacuum, and to seek input from people who represent the end user. In other words, talk to people. EBE literature refers to this process as customer discovery, where the goal is not to pitch the business idea, but to listen to people's experiences within the specific domain that you aim to influence, and importantly, to allow your core assumptions to be challenged and reshaped by what you hear. As a participant in the NSF I-Core program a few years ago, I've conducted interviews with, at this point, over 100 professionals across the building design, construction, and product manufacturing industries to advance an ongoing material research project toward commercialization. This experience has been eye-opening. It's kind of like drawing the curtain back to see how various forces played out: competing values, sustainability goals, labor issues, costs, logistical concerns, all to yield a particular built result. And especially when unconventional materials or building methods are involved, it's especially informative to understand how these result from a coordinated effort among architects, but also a whole host of other stakeholders. It decenters the architect from our imaginations of architectural innovation, an important lesson for the cosmopolitan architect. To recreate this experience in the classroom the first couple years, we started with a selection of building case studies and remote talks from guest experts. Students worked in groups to research specific products or systems used in these projects and talk to people who have specified, used, or designed those products, starting with our guest. By getting out of the classroom and offline, students conducted customer discovery style interviews to gather multiple perspectives originating from their case study building. The idea was not to analyze the building formally or programmatically, but to forensically reconstruct the decision factors behind the material choices, why and how material innovation was prioritized. Applying another EBE tool, students mapped the industry ecosystems around each product, encompassing supply chains, regulatory influences, and market forces. Students gained a business-informed perspective on the various decisions and transactions that accrue into a built reality. Each group then drew conclusions about values, incentives, and missed opportunities in the field of material innovation they researched. One of the refrains that we like to use in the course is, if fill-in-the-blank construction technology is so amazing, sustainable, ethical, high performance, why isn't it used everywhere by everyone? And there's usually an interesting answer to that. Finally, students packaged their research as supporting evidence for a new business venture they proposed, typically a modification or extension of the one they researched. The final deliverable is a short pitch, drawing from their interviews to describe the need or problem their proposal is addressing from a very human perspective. So while the first two versions of the seminar focused on material innovation more broadly, and while these courses were really, productive pedagogical experiments, for the third iteration of the course, I wanted to focus on embodied carbon for reasons I think everyone in the room can understand. What could we learn about strategies to decarbonize the building industry from talking to professionals at the forefront of this effort? By getting out of the building and learning from current material research and product development, Can we establish new alliances between design and the business of building buildings to reduce architecture's physical impacts on the planet? And in this iteration, in winter 2022, the guest experts who presented remotely, we opened that up as a public lecture series. So while tools like life cycle assessments and embodied carbon calculations are very important in helping us evaluate material innovation, this course aims to empower students with tools for locating, engaging, and learning from active sites of knowledge production out there in the field. By forming a clear picture of the complex and ever-changing web of information, practices, policies, businesses, and technologies that constitute building industries, students in the course emerge better equipped to formulate good questions, build evidence, challenge the status quo, and shape new design-informed practices. And now I'm going to turn it back over to Joe and Katie.